Hello everyone, welcome to our channel Braino Academy. I hope you are all good. In this session, we are going to discuss this question. As you can see here, if angle A and angle B are acute angles such that cos A is equal to cos B, then show that angle A is equal to angle B. How to prove that the angle A is equal to angle B if angle A and angle B are acute angles? So now as you can see here, and just let us assume we are having two right angle triangles. You can see here, yeah, it is a one triangle and it is the another triangle, right? So I'm just going to I'm going to give the alphabetical letters to the sides. As you can see here, let it be P and this is B, like let it be A and this is be Q. As you can see here, it is the angle A, right? Angle A is the acute angle. So as you can see here, this line, these two lines making an angle here, this angle is the acute angle because it is less than 90 degree. If the angle is less than 90 degree, the angle is known as acute angle. Like the same here, it is the acute angle, therefore it is the angle B, right? I am giving the alphabetical letters here. Let it be C and D, right? So as you can see here we are having two acute angles, angle A and angle B. I just assume there are two right angle triangles and I then draw the angle A and angle B and given the alphabetical letters to the points, to the vertex. Now just go to the question such that they have given to us that cos A is equal to cos B. They given that cos A is equal to cos B, therefore cos A is equal to cos B. What is the formula for cos A? So we should have to write the side opposite to angle A. What is the side opposite to angle A? It is the opposite side. It is a 90 degree. The side opposite to 90 degree is known as hypotenuse. And the last side is the adjacent one. As you can see here, opposite to angle B is known as opposite side. Opposite to 90 degree is the hypotenuse side. And the last side is the adjacent side. So now, as the given information is cos A is equal to cos B, what is the formula for the cos A? I very clearly given, if cos theta has been given to us, then the formula for cos theta in the trigonometric ratio is equal to adjacent upon hypotenuse. So I'm just going to apply for cos A adjacent upon hypotenuse, that is AQ upon hypotenuse AP is equal to cos B. So cos B adjacent is BD upon hypotenuse is BC, right? What I'm going to do is that I'm just bringing this AP to this side, so it will go to the numerator, and I'm taking this BD to this side. It will come to denominator as it is in the numerator, right? That means it will become as AQ upon BD is equal to AP upon BC. So now just see this expression. As you can see, AQ is the adjacent side of one triangle upon BD, adjacent side of other triangle. So adjacent side of one triangle upon adjacent side of other triangle is equal to AP, hypotenuse of one triangle upon hypotenuse of other triangle. If the condition is like this, that means it is the similar triangles given to us, right? So what is that similar triangle condition? Similar triangle is saying to us, if the two triangles adjacent ratio is equal to two triangles hypotenuse ratio is equal to two triangles opposite ratio, that is PQ upon CD. PQ upon CD, then we can say that the given triangle is the similar triangles. Now I'm going to just assume, I'm just going to find PQ upon CD. If this PQ upon CD is equal to these two ratios, if PQ upon CD ratio is equal to these ratios, then I can say that the given triangle is the similar triangle. Therefore the side ratio is going to be equal and the angles are also going to be equal. Now so I'm just going to find first PQ upon CD. I'm just assuming that AQ upon BD is equal to AP upon BC is equal to K. As I'm going to get some ratio, I'm assuming that ratio as K, right? So AQ upon BD is equal to AP upon BC is equal to K. Now I'm going to the PQ upon CD. PQ upon CD. How to find PQ upon CD? So for PQ, how I'm going to find PQ? As you know already, for the third side we should have to apply the Pythagoras theorem. Here I'm going to apply the same for PQ. PQ square, right? That means hypotenuse square AP whole square is equal to, for this triangle PAQ, AP square is equal to PQ square plus AQ square. That means sum of the squares of the other two sides. Therefore PQ square, I just need the PQ square. Therefore PQ square is equal to, this AQ square will go to left hand side. That will be a change in the sign as it is moving from right to left. Therefore it will become as AP square minus AQ square. As you can see, it is PQ whole square. When this square goes to the right hand side, it will become as root. Therefore PQ is equal to under root over AP whole square minus AQ whole square. Right. So it is the value for the PQ. I am going to put this value here. PQ is equal to under root over AP square minus AQ square upon, it is CD. As you can see here, CD, it is the opposite side. Then it will become as, you just try it out and just get me the answer for the CD by applying the Pythagoras theorem. I am just writing out the answer here. CD is equal to, right here, CD is equal to under root over BC square minus BD square. Right. BC square minus BD square. I just found out the value for the CD by applying the Pythagoras theorem. Just you apply it in your notebook. You will get the answer as under root over BC square minus BD square. Right. As you can see here, AP upon BC is equal to K. So instead of writing AP, I can also write it as K into BC. I am having here two expressions. As you can see, I am writing here AQ upon BD is equal to K. Therefore instead of AQ, I can write it as K into BD. This AQ is equal to K into BD. Right. Like the same, I am applying for this expression AP upon BC is equal to also K. AP upon BC is also equal to K. Therefore for AP I can write it as K into BC. So instead of AQ I can write K into BD. Instead of AP I can write it as K into BC. I am just going to apply this. Right. It will become as under root over AP is nothing but K into BC whole square. K into BC whole square minus AQ. AQ is nothing but K into BD whole square. K into BD whole square upon under root over BC square minus BD square. Right. As you can now see the expression, it is K square BC square minus K square BD square. It is the root, it is also the root. So I can write it in single equation. It will become as K square BC square minus K square BD square upon BC square minus BD square. So if I am taking the K square outside, I'm just rubbing out this question here. Yeah, I'm rubbing out the question here. What is our question? We should have to show that the angle A is equal to angle B. Right. Okay. So here PQ upon CD is equal to, I'm just taking the common one, K square outside, it will come as BC square minus BD square upon it is also BC square minus BD square. Therefore these two are getting cancelled out each other. Then it will become as under root over K square root and getting cancelled out each other, and it will become as K. Therefore PQ upon CD ratio is equal to K. Therefore as you can see here, AQ upon BD ratio is equal to AP upon BC. This ratio is also equal to K. So I can write AQ upon BD is equal to AP upon BC is equal to PQ upon CD is equal to K. Therefore, it is a similar triangle property. Triangle PQA is similar to triangle CDB. Triangle CDB. Therefore, angle A is equal to angle B. Hence, proved. As you can see here, we proved angle A is equal to angle B, as we are getting the height of one ratio, that means opposite side of one triangle upon opposite side of another triangle is equal to the ratio of the two adjacent of the two right angle triangles ratio, and the ratio of hypotenuse of those two right angle triangles is equal to K. Therefore, I am getting the ratios same. As the ratios are same, I can say that the given triangles are similar triangles. Therefore, my angles are also going to be the same. Therefore, angle A is equal to angle B. Hence, proved.